In this lesson, let's learn about proofs for discriminated expressions for quadratic functions and quadratic equations. 二次関数と二次方程式、判別式の証明。First, a review of discriminated equations. Let D be the discriminant of the quadratic equation ax squared plus bx plus c equals 0. The value of D allows us to determine the number of real solutions to the quadratic equation. If D is greater than 0, then there are two different real solutions. When D is equal to 0, there are multiple identical solutions but only one, so a total of one real solution. When D is less than 0, it has no real solutions. Now we will prove this discriminant formula. First, let the equations on the right be 1, 2, and 3 respectively. The solution of 1 is x equals 4 and 2. There are two real solutions. The solution for 2 is x equals 3. There is one real solution. Finally, the equation for 3 is x minus 3 in parentheses times 2 plus 1 equals 0. Since the left-hand side is always greater than 0, the equation has no real solutions. Next, we apply the quadratic formula to 1, 2, and 3. The equation for 1 looks like this. The equation for 2 looks like this. Finally, the equation for 3 looks like this. In summary, what we have done is shown on the right. Pay attention to what's inside of the root. When the root is greater than 0, there are two real solutions. When it is equal to 0, there is one real solution. And when it is less than 0, there are no real solutions. In the quadratic formula, the inside of the root sign is b squared minus 4ac. So we know we can determine the number of solutions. Now let's solve some practice problems. Give the number of solutions to the following quadratic equation. Press the pause button and try to solve this practice problem. Once you're finished, press the resume button and mark what you got correct. Now let's check our answers. Let D be the discriminant equation of each quadratic equation. The discriminant of problem number 1 is D equals 54. 54 is greater than 0, so D is greater than 0. Therefore, there are two real solutions. Similarly, solving for problems number 2 and 3, problem number 2 has no real number solutions because D is less than 0. And for problem number 3, we have multiple identical solutions, so there's a total of one real solution at D equals 0. Were you able to answer correctly? Finally, let's review what we have learned. Let D be the discriminant of the quadratic equation ax squared plus bx plus c equals 0. The value of D allows us to determine the number of real solutions to the quadratic equation. If D is greater than 0, then there are two different real solutions. When D is equal to 0, there are multiple identical solutions but only one, so one real solution. And when D is less than 0, there are no real solutions. We found that the number of real solutions is determined by the b squared minus 4ac in the root sign of the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac over 2a. That concludes this lesson.